Hello, everyone, and thank you for joining our webinar about OT vulnerability management, what works and what fails. And we will be focusing on energy systems, so the power grid, the OT in the power grid in general. However, I'm sure that there are a lot of things to take away also for OT systems in critical infrastructure in general and not just for the power grid. However, for my examples today, I will be focusing on power plants and control centers and substations. And I see there are still a lot of people joining. Thank you for that. And while people are joining, I think we can do a little warm-up round. So as a little warm-up question, I've got a vulnerability scanning exercise for you. So this OT system here, scan it for vulnerabilities and tell me if you detect something here. So I think if you did not detect the big physical vulnerability that is present here, then maybe you should check out a doctor. So we've got, of course, physical measures to do as well, physical vulnerabilities in substations as well that we need to take care of. However, our focus today will be on cyber vulnerabilities. And when you have questions about any of these topics here, then please feel free to drop a question here with the chat function. And there's no stage fright here. You don't need to worry that everybody else sees your question. You can just send the question directly to me or to the host of this session, which is my colleague Peste, and she will also then forward the questions to me. And so you can ask them privately if you want. And then in the end of the session today, I will share and I will try to answer all of your questions if the time allows it. So please feel free there. And there is always the most frequent question. Will we get the slides and will we get the recording of this webinar? So yes, the answer is you will get a recording of this webinar. Give us a couple of days and then we will forward the recording to you. So let's go with the topic of vulnerability management in OT systems. And this is how an AI image generator imagines a physical vulnerability in a substation. But why are we doing actually OT vulnerability management in the power grid, in energy systems? Because anyway, do we even have to do it? We cannot patch these devices anyway. We cannot roll out firmware updates as we will discuss later. Some people say that. And do we really have to do that? So yes, there are regulatory requirements for vulnerability management in many countries. So many national regulations directly require the implementation and documentation of vulnerability management processes. So for example, the EU NIS2 directive quite specifically mentions the handling of vulnerabilities and the processes for vulnerability management. And all the EU member states need to implement laws which are at least covering this and not less than that. So all EU countries will and do require that. And since it's an EU directive already, state-owned utilities in the EU already need to adhere to this because it's going to be law anyway. We have another example, Switzerland, and they quite specifically addressed this in their national regulations regarding security of critical infrastructure. And they specifically even mention operative equipment in their assessment tool for that regulation. So I saw that there are some customers and members here from Switzerland in this webinar. Greetings from here. So there it is also clearly stated. Vulnerability management is part of also the risk management processes. So any utility which is certified against ISO 27000, that is also part of that process. And cyber insurances, which have been a topic over the last years more and more, they don't they only protect you against the damage, but they don't protect you against the effort of creating proper security processes. So these cyber insurances also require proper risk management, including vulnerability management there. So in almost all countries, there is vulnerability management laws coming, or they have been in place already for years. Also in Germany, for example, which were among the first where this is mandatory. This webinar is intended for IT experts. IT experts who have to deal with OT security and vulnerabilities in the OT area. And I would like to give you a bit of an introduction of the OT devices that are there in the power grid, for example. So there are most of these devices are protection and control and SCADA devices, because in control centers, in many cases, the vendor of the control system is also covering vulnerability management more and more, at least for newer control centers. But the majority of these small OT devices that need to be managed are protection and control devices in the power plants and in the substations. So protection devices protect power lines and transformers from faults. That's among their jobs. And these sound to be like quite primitive systems. However, they are not at all primitive. They are in fact small computers which have measurement interfaces, but they also have multiple Ethernet ports with IPv4 networking. They have web interfaces. They have SNMP available, and in many substations, the SNMP is activated. So there is an operating system on it, and there is all kinds of vulnerabilities included in these libraries and components that are used there. And so IT people, I hear them often say, power utilities must start patching their devices now. Why is patching so difficult in the power grid? You install a new firmware on your printer, you install a new firmware on your smartphone. So why are you not installing the newest and most secure firmware in these critical devices protecting the critical infrastructure, the backbone of our society? Why are you not patching it? So, and I would like to give you some insight here. I would like to explain this now, why it is so difficult. And in the power grid, the situation is a bit special. So generally with OT, but especially in the power grid, would you do this? Would you do an over-the-air update of a cabin pressure controller in the airplane while you're flying in it? I think you would not. So you need downtimes. The reason number one why patching is so difficult in the power grid is downtimes. So you need to disconnect power lines or transformers when you want to patch the devices, and it often takes months to schedule downtimes in the dispatching of the grid. So you need to wait for months and longer until one power line can be de-energized. And in fact, switching off an entire transformer is rarely ever possible. Normally, you can only switch off individual feeders connected to the transformer, but never the whole transformer can be switched off. And especially not a whole substation also cannot be switched off. So you need downtimes, and it takes months to schedule that. So there's a lot of planning involved, and you cannot simply patch every substation, every device so often. But the more important reason and the more difficult reason is reason number two, and that is testing. Testing is so difficult. This is an aerial picture of a substation, and you see all these connections in there, and all these are switching elements. So there are so many switching combinations possible, and there is a logic needed to make sure that you're not producing a short circuit with the switching that you're doing here. So it is complex logic that needs to be programmed specifically for a particular substation and its circuit around it. And when you introduce a firmware update, this patch will have new code, and new code has new bugs. So patches behave differently on different hardware versions even. So you have a wide variety of ages of devices and different hardware components used in there, and the firmware update might behave differently on the different hardware versions. And I've talked with many customers who had exactly this situation. And the next point is you're programming this logic that you see here, with this intricate logic with so many switching combinations that you have here. This needs to be programmed in a PLC logic with the same as it's done in factory automation. And this PLC logic, the firmware update can have side effects there. And I've also talked to customers who told me that they had some flaws in the PLC logic, which was then triggered by the firmware update, which behaved slightly different. And this can then be different from substation to substation. So even if you test your patch in a lab in this environment, it is not clear that it will directly operate in the same way in this substation that we have here in the picture. So how do I test all of these functions and switching combinations in here? In reality, it's a bit sad that in many cases, these logic combinations can only be tested by executing them, by really switching the breakers in the yard of this substation. And obviously, this cannot be done. And we're again talking about de-energizing power lines, which is not possible. So the result is that applying a patch can pose a higher operational risk than not applying that security patch. So this gives another additional dimension to risk management that you actually need to justify if the operational risk is worth it to fix a cyber risk. And this is why vulnerability management is so tricky in the power grid, and why it is so important to make sure that you're only patching what's absolutely necessary from a risk perspective. Looking at ISO 27000, here in part 2, chapter 8.8, there is the vulnerability management process defined. And I'm trying to structure the rest of my webinar roughly along this process. So we have 3 major steps in this process: identification, assessment, and then mitigation of the vulnerabilities. In the identification step, it is first important to define the roles and responsibilities in your organization, and then to gather the information, the security advisory documents about what you're affected by. And then you need to develop some kind of vulnerability detection capabilities. And I will later talk about how vulnerability scanning will not work. In the assessment step, you will analyze the security advisory. So you identify the risks. Do these security advisories really match my systems? Is it really something that can be exploited? And then you define the specific treatment measures per device. And in the mitigation step, you're executing that. So you've planned to roll out a patch. So you need to test that patch and evaluate it if it can be rolled out really in these substations or in the power plant. And if it's not possible to apply the patch because no downtime is can be scheduled anytime soon, you need decide on some substitute measures. And you will not roll out each patch immediately. You will time it when there is the next maintenance window in that system, for example. So let's go to the identification step first. Let's talk about vulnerability scanning. And my statement is vulnerability scanning, like Nessus scanning or something like that, doesn't work for devices. It only works for software. So it works for a server, a daemon running somewhere, but it doesn't work for whole devices. It doesn't even work for my Android phone. It cannot be scanned from the outside because there are so many components running in my phone, and not all of them are visible from the outside. So a device, even in the power grid nowadays, they consist of hundreds of software components. And the vendor must monitor all components. And if one of the vulnerabilities in one of the components is reachable from the outside, is exploitable from the outside in the end product, then they must inform their customers of the risk that they are exposed to. But many vulnerabilities are not exploitable from the outside. So the Linux kernel has, I don't know, 30 million lines of code. And in that protective relay, maybe only 10 million lines of code are used. So all the bugs in the other 20 million lines of code are not relevant for the customers of this device. So it would be an extreme burden if the end customers need to deal with all the vulnerabilities in the Linux kernel, because there are so many of them. They should only deal with those who were selected by the vendor that they are relevant for this customer. But if you're not a developer on that software, you cannot know which vulnerabilities break through. So I wrote here this in red, must, because it's not like this yet. So this will be the case soon, thanks to the EU Cyber Resilience Act. And this is something like a trade barrier where every product, including consumer product, that is purchased in the EU needs to fulfill this. The vendors need to do this. Until today, they did not need to do that, but they will have to do that for products released in the future. And when such a risk breaks through, the vendor needs to issue a security warning to the customers. The warning is called security advisory document, and it tells you when am I affected and what can I do to protect myself against that risk. And one security advisory document typically consists of multiple vulnerabilities. So multiple CVEs are included in one security advisory. And then the vendor combines everything together into one, say, PDF document or email or website page, and that is how one advisory is communicated. Now that we know this, we cannot scan it in the network like this. We need to know what device it is and then compare that against security advisories. This is the process what we need to use in practice in the OT. So we've got an asset inventory. This describes the devices that are used in my network. So we've got all the product names, we've got the types and models and configuration with modules and so on, and the software version, the firmware version of the device. And this I will compare against my stack of security advisory documents. And then I can find out if one of my devices is actually described in the security advisories or the other way around. And this will give me the list of vulnerabilities of one device. So that means to find out the vulnerabilities of one device, I need the information about the type and make and model, configuration, firmware version. And when I have this, I can look through my security advisory documents if anything is mentioned for that device and firmware version. Again, if you have questions, don't forget about the chat button. Feel free to drop me a question using the chat button. I will try to answer them at the end of this webinar. So I now have the list of vulnerabilities. So the security advisories I need to consider for the power grid. Let's have a look at this. So we've got a security vulnerability database specifically made for the OT. And these are now some statistics I will share along the webinar, how what we can find out from that OT vulnerability database. So this is the number of vulnerabilities that were published by OT vendors every year. So we monitor 38 different vendors. In total, we collected over 12,000 different CVEs or vulnerabilities, and these were described in over 5,000 security advisory documents that we've worked through. And from that, we can say that there are about to be every year about 600 security advisory documents published by OT vendors. So you can also assume that for 2025, we already are in that ballpark area of half of it, that or more than 300 security advisory documents were also published for 2025. So roughly every year, 600 new advisories are coming out that we need to consider. So to look if I am affected by a security advisory document, I need to compare my devices against the security advisories on the right. On the right, these are some examples of a security advisory document. This here was published by the CISA ICS CERT database. And we now need to compare if I have the specific device type, module configuration, and the firmware version that are described here in the security advisories. And then I need to read through the text to find out if the affected services, such as SNMP or web interface, are also activated in this device. And then I know, okay, I am affected by this security advisory document. This is an example of a security advisory document. And please note that the security advisory document here is written for a specific communication module of a device and the firmware version of that communication module. So it's not referring to the device itself, it's a protection relay. It is referring to a communication module of that device. So in your asset inventory, you need to know, do I have this type of device which uses this communication module, and then the firmware version of that communication module used on that device. So it is rather complex what is needed from the asset inventory to do OT vulnerability management in the power grid. So this is now the vulnerability matching process. I need to find out if I have one of these devices and firmware versions that are mentioned here. So until now, until today, since the year 2009, where we have the first advisories collected, there have been over 5,000 OT advisories published, and they are located in our database. And they all need to be analyzed to get to the state of today. And then every year, 600 new advisories are coming out. Each and every one of these security advisories have cover about 3 to 4 different CVEs, and they describe about 10 to 20 different device types of OT devices that are affected by it. And I've talked to several utilities already, and they confirmed that sometimes it can take just 10 minutes to recognize, okay, we don't use this device, this is irrelevant, or it can take over 8 hours of personal effort to just decide if we are affected. Do we have this device and firmware version that is affected by this advisory? And so this is quite a time-consuming process, and this time-consuming process can be automated using a StationGuard GridOps, which performs this vulnerability matching automatically using knowledge about these devices. There are some challenges in the vulnerability management process, and I would like to outline them, and I would also like to give you a few solutions for these challenges. The first one is, where in the first place do I actually get all of these security advisory documents? I have mentioned ICS CERT database from CISA. The problem is CISA is not complete and it's not up to date. For several vendors, CISA does not update the advisories. They may take in the newest one, but maybe they don't have all of it. And so CISA is not, ICS CERT is not the source that can be used if you really want to catch all the vulnerabilities of your device. So you need to subscribe separately to each vendor to receive their advisories. And this can be on their website and over email. And this is how you get them. Unfortunately, there is no central database for that. Vulnerability matching, so you need to take care of the question is if you're using a certain firmware version on a certain expansion card of the device. Next part is you need quite a precise asset inventory. And the question is, how do you get this precise asset inventory information so that you can make the decision if you have that equipment or not? Then you need to decide per device. You need to make the assessment if you want to patch there, when to patch, and accept the risk. And then you need to document your decisions for a later audit. And what shall you do until it is patched? So I mentioned it can take long until a patching cycle can happen. So what are typical technical mitigation measures? And here the question is, the key question is, would I detect an exploitation of the vulnerability? So if it is a critical vulnerability, maybe the exploitation will not directly cause a blackout. Maybe it's just an intermediate step. So the question is, can I detect if somebody exploits it? And this brings us back to the topic of intrusion detection. And when we look at our tools, we can support you in all of these steps. So StationGuard GridOps has a database on-premise which contains all security advisories and vulnerabilities of 38 different vendors. We have matching heuristics for most of the OT devices used in the power grid. And we have dedicated algorithms for the different types so that these security advisories are matched correctly to the device so that you only have the vulnerabilities which are really relevant for that device. And StationGuard, the intrusion detection system, is present as a sensor in the network and can collect automatically asset inventory information. I will explain that in a minute. And also the documentation of your decisions, if you want to patch or accept a risk, this is also available in GridOps. And with an intrusion detection system in the network, you don't need to patch everything. So StationGuard can collect in the network information about all the assets that are visible in the network. So it can discover the network automatically, note down all the assets in the network, and then it can even actively interrogate the device and read out their nameplate information, and then you get precisely the information of the firmware and the type and the model and so on. StationGuard can also import the engineering files in the 6150 SCL file. You can import your asset inventory also as a CSV. And even if it's not a 6150 plant, you can leverage our import tools to import vendor project files. So also for power plants and other stations, for several major vendors, we provide importer tools where you can read in the original vendor project file, and then you also get this information extracted. And GridOps provides export and import functions to synchronize with other databases or CMDBs, as it's called in the IT. So this is so much about asset inventory. Next step in the vulnerability management process is a step of assessment and mitigation, so-called exposure management. I have now my list of vulnerabilities for one device, and now I need to assess per device what to do. And for this, it's important to know that each vulnerability has a CVSS score, and that is this orange bar that you see here. This is what the vendor assessed. How easy is it to exploit? How bad is it? And then next point is not every device type is critical, and not every grid segment is equally critical. And this information can be used to decide on the next step, on the mitigation options. And in GridOps, you can then make your decision either in bulk for many devices or specifically different for different devices. And there you can manage the resolution for the device. So you can decide if it shall be patched immediately or in the next cycle, and there are plenty of options there. And you can also document it with your own comment. And this is important for a later audit of your vulnerability management efforts. So there are 38 vendors that we're covering in this database. This vendor list not only contains OT manufacturers of the automation devices, but it also contains network equipment. So switches which are typically used in OT networks and other communication equipment and firewalls that are used there. So these are covered in GridOps, and this database and GridOps is available offline, on-premise, in that isolated network zone. And it receives its update, if you want, also over a file-based update process, so you can securely transfer the updates into that isolated OT zone. And this is how the database, vulnerability database, is updated. So how do we automate the task of vulnerability matching? This requires a lot of expert knowledge. So how does this work? So we've got our OT vulnerability database. I will explain how we create it. And then there is a database with device type meta information. So we know for all the OT devices what kind of device types do the different vendors have, and what kind of expansion modules, and which firmware versions are common for these expansion cards and the device types. And with this meta information, we are building custom matching heuristics which are specific for the specific device type. So for Hitachi and ABB and Siemens and so on, for all of these OT devices, we have, even for the specific types, we have different matching heuristics. So A8000 is different than CPROTEC 4, is different than CPROTEC 5, and so on. And this is how we create our vulnerability database. I mentioned there is no central repository of advisory documents, unfortunately. CISA ICS cert is not complete. And therefore, we're using web crawlers, which are scanning the vendor databases every night, and they are watching the vendor websites for new security advisories. We also have other sources which are continuously scanned. And then we are importing these advisory documents into our database. Fortunately, some vendors have machine-readable security advisories in the CSAF format. If you want to read more about CSAF, here is a link. And these vulnerabilities are collected and corrected, and we're also in contact with these vendors to give them feedback about what can be improved there. Sometimes there are some bugs in there as well, or mistakes. Then some vendors, or several vendors, only publish PDF files or emails or texts on their websites, and these are also scanned and added to our offline on-premise database. And for all of these advisories, we create the CSAF files ourselves. So that means we are converting them to machine-readable format, which we're using. And then we are adding metadata, meta information for this vulnerability matching, where you map different security advisory documents to the devices. And with this, we also expand the device type database and the matching heuristics. And this all is contained in one vulnerability database update. So this database gives us some interesting insights as well. So when we query this database and look for different data in there, these are some things which I would like to share with you now. So when we look into the attack vectors described in the CVEs, 76% of the attack vectors of the OT vulnerabilities that we have in this database, 12,000 CVEs, 76% are exploitable over the network. And when you look at the most critical vulnerabilities, then the critical vulnerabilities are typically or mostly also exploitable over the network. And the other way around, if they are exploitable over the network, they tend to be also very critical. So we have the situation that we've got a lot happening on the network, and the network is a big attack vector. So let's have a look at a typical plant network. So this is a network that is typical in a power plant or in a substation, close to a power plant or substation network. In red, there are the attack vectors numbered, and looking again at my pie chart that I mentioned before, the network-based vulnerabilities, which are 76%, they are exploitable remotely and locally, which means the attack vectors 1, 2, 4, and 5 in this picture. All of them are relevant for the majority of the vulnerabilities that are present in OT. And then 7%, the salmon color that I chose here, can be exploited locally. So that means via the local station network or plant network that is there. And so if you're there with a maintenance engineering PC, or if you're there with a test set and connected to the network, then these vulnerabilities can be exploited directly locally. So it is a large number of vulnerabilities in the network. And this means that network monitoring in these plants makes sense, not just to detect what is going on, but it also makes sense because intrusion detection in this network may be sufficient as a mitigation measure for many vulnerabilities. And we are serving several utilities who chose to install an intrusion detection system in all their substations because they cannot patch so frequently. So let's look into further reading if you want to know more about OT vulnerability management. And I saw some people who registered for this webinar. I noticed that they speak German. So if some of you are interested, I really want to recommend you the Protect Your Grid conference, which happens in Frankfurt on September 24 this year. And you can find out more information at protectyourgrid.eu. And in this conference, there are many utilities and also the German Federal Office sharing hands-on experience, and the topic of vulnerability management is covered by many of them. Among other topics is also practical experience in intrusion detection, but also about penetration tests in OT network and what the experiences are there, and also experiences about establishing an OT SOC, a security operations center in a utility. So maybe you want to have a look at the Protect Your Grid conference happening on September 24 in Frankfurt. Then I cited several statistics from our OT Vulnerability Report 2024, which you also might want to have a look there. And a deeper dive into security advisory documents and how to use them and what are the specifics behind that, also that you can find on our website at omicroncybersecurity.com. And that brings me to the conclusion of this webinar. So you don't have to patch and treat every vulnerability, but you need to be aware of them, and you only need to patch the most critical ones, which you cannot mitigate otherwise. An effective vulnerability management process and documenting it is not a nice to have, but it's a requirement to have because of national regulations in many countries worldwide. And if you approach this pragmatically, start somewhere and with suitable tools, then every organization can manage OT vulnerabilities better. And with that, I want to thank you for your attention. And if you have further questions, if you would like to know more, or if you would like to see a demo of these tools in action, we just opened a Slido questionnaire where we ask you if you would like to speak to one of our experts. If you would like to see a demo or so, then please click on yes, please. And then we can get in touch with you, and we can show you how this could be done in your organization. And I would also be happy if you give me some feedback about the webinar today. Did you like the contents? Did you like the presentation or not? And maybe you have some suggestions on what to improve. I'm very happy to receive your open feedback here. And that brings me now to questions. So if you have questions, feel free to put them into with the chat function here. You can message me privately, or you can message my colleague Beste, and then I will try to answer your questions here. So let's have a look into the first question. We know that CVSS score is not always relevant because context should also be taken into account. Any option to ponder CVSS? Yeah, mostly used until today is CVSS version 3, but CVSS version 4 was also released. And if you look into CVSS version 4, there are also some environmental scores there. So you mentioned it here as the context, which should be taken into account. CVSS version 4 provides the option to include the context, the environment, and there are some additional scores that are there. Until now, not so many vendor security advisories were published yet with CVSS 4. However, if more of them are available, then also our products will display them. So yes, we are internally working already on CVSS 4, and now we are waiting on more CVEs to be released with CVSS 4. It is looking good. So thank you for your question. Then another question, is this solution only used for power grids, or can it also be used for other OT infrastructures? So we focused, because we had to start somewhere, so we focused with 38 vendors to power grid vendors which are typically used in the power grid. However, when we cover ABB, we cover all the vulnerabilities from ABB, also industrial automation. When we cover, say, Schneider Electric, we cover all the vulnerabilities from Schneider Electric, and same also for GE. And because of this, we do also cover vulnerabilities for other industries, because these automation devices are also used in power plants and so on. So this is perfectly supported. However, with our products, we're currently focusing on energy systems. So another question, does the conclusion regarding patching that we don't need to treat every vulnerability also apply to virtualized assets in the OT? So virtualized assets in the OT, I think you mean running them as a virtual machine. So it's the same case there. If you only need to patch when the security risk is higher than the operational risk that is introduced through patching. That should be a pragmatic process for doing it. So if the operational risk is low when you patch a virtualized asset, then go ahead, because it patches a security risk. So if you maintain that balance, the answer is clear. Yeah, virtualization in digital substation is a topic on a known webinar, also a very interesting topic. Thank you for that question. Are there any other questions? So we are nearing towards the end of the time. I see people are typing questions. So thank you for the comments, and thank you also for the questions. If you want our experts to get in touch with you, please approach us, contact us over the website or here with this poll. And with that, I want to thank you very much for your attention and hope to see you soon. Goodbye.